we have around 7 students or 6 students now. I will wait for another 2 minutes. Then we can start, inshallah. Okay, seems no more students will coming soon. It's considered first lecture for most of you. Last lecture we took first chapter. Actually, it's just introduction. Have some terms and it's not too difficult for you just to read it. Today, inshallah, we will start in chapter 3. Sorry, chapter 2 not in our course. It's also more terms and it's not important for us. In chapter 3, inshallah, we will speak about ER diagram. Let me share my screen with you. Okay, chapter 3. If you have, I know that some students took the course before. If you have previous lecture note, please do not depend on it because I give my lecture note with some comments, and sometimes I remove some parts, I add some comments, some parts. So it's better if you use our lecture note here, our slides, with the book also. It's good if you look in the book, and especially for examples and exercises. Okay, data modeling using entity relationship model. At the beginning, when you design a database system, you have two parts: database design and application design. Like, for example, if you're designing a website that containing database, you will have database design and application design. In this course, It's not our job to speak about application design. We focus in database design. Any design, database design, application design, is starting with collecting the data. For example, the term mini world means part from real world. For example, you speak about application to manage university. Then this application, university application, consider mini world. Okay, it's like present for you part from a real world. Okay, this is a term. It's not too important to define something like this. Here, first step, you need to collect your requirement and start to understand, analyze your requirement. After collecting and analyzing this requirement, you have two parts. You have database design, which is here, and this is our main concern, and application design, which is here, and it's out of our scope, not in our course. Okay, to design your database, first step, after collecting the requirements and analyzing these requirements to know your functions in your application and to know the data requirements. After you know your data requirements, you start to organize this data requirement in a model, in a diagram. We call this conceptual design. Conceptual design, you want to simplify this design, this data requirement in one diagram, because diagrams usually better for understanding and also will help you to make your database without any problem in integrity and redundancy and all this issue. We will take all this issue later, inshallah, in mapping and normalization. Okay. Sorry, cannot hear you. You are asking, or it's just if you don't have any question, please turn off your mic. Saad and Mustafa, if you don't have any question, Saad, you are asking, or you forget to turn off your mic. Saad, I cannot hear you. If you have any question, just write it. Okay. Okay. In conceptual design, you need to Saad, I told you another time, I cannot hear you. If you have a question, yes. Just write your question. Yes. Yes. Yes, Doctor, yes. Okay, come on. Go ahead. You have a question? If no, turn off your mic, please. Unfortunately, I cannot hear you, so you can write your question. Just write your question. It will be better because I cannot hear you. Okay, conceptual design. You need to model your data requirement, or draw a diagram to show your data requirement. We have many types of diagram. The most common diagram, diagram, ERD, and class diagram in the UML. Actually, it's new unified modeling language. We have class diagram is for object-oriented data. So we focus actually in ER diagram, but we will take a look for class diagram. After you draw your ER diagram, you need to map it to a relational data model. We will speak about mapping from ER diagram to relational data model, inshallah, later. Then you need to build your database using SQL, especially, of course, data description language. Okay, DDL, data description language. It's part from SQL to build your tables and relation between the tables. Okay, then this steps to build or to design your database. Then you start by implementing. You start to implement this database and application. Of course, if you look here, we not speak too much about application design. We focus here in database design. Then in this unit or this chapter, we will speak about ER diagram, and we will take also one example from UML. If we have time, maybe we can speak a little bit about chapter 4 and enhanced ER diagram. If we don't have time, it's okay. We can just ignore it. Okay, I will not focus too much about terms, just specific terms that we need for ER diagram. ER diagram or ER terms mean entity relationship. Entity relationship. Okay, the main example during this book speak about the company database, and there's another example for database speak about university database. I will not read this now. We will take this description for company database as example after finishing all the terms and all issues about ER diagram. Then we will take this example and start extract the entities and extract the attributes from this description to know how to draw ER diagram from the description. Usually, Software engineering will do some meeting with the customers and ask them about their application and what type of data they need to store. And they start to describe the need their application. From this description, like this description, the job for you as database designer to extract the data and find ER diagram first, then mapping this ER diagram to relational model. Later we will speak about relational model in another chapter. So we focus here in this chapter about how to draw ER diagram from a description. After finish this chapter, inshallah, I will give homework also have description and you need to draw ER diagram. Then later we will look for this example. Okay, ER diagram. ER diagram consists from three parts or three things. We have entity type and attributes and relationship types. What's the meaning of entity? Entity, it's a specific object or things that you need to keep data about it or to represent it in your database. For example, if we have a mini word or database about university, what things in the university system that you need to keep data? For example, the courses, the sections, the stuff. Okay, each one of this consider entity because you need to represent this entity and keep data about this entity or about this object in your database. So for the company database, for example, you have employees like employee Ahmad, employee Ali, employee X, employee Y. Okay, you have departments like department X, department Y, research department, accountant department. Okay, you have, for example, products. You need to keep track or represent this product in your database, product X, product Y. Okay, then this is the entity. Entity, it's specific things or objects that you need to present it to keep data about it in the database. Each entity have attributes. Attributes or property, this items or data that you want to keep about this entities. Like if you have employee, then you have employee name, employee address, SSN. This means social security number or ID number in some country. Okay, gender and birth date. If each one of this is attribute or data or items that you need to keep about this entity. Okay. Okay, attributes in ER diagram. We present attributes as an oval. Sorry, entity in ER diagram, we present entity as an rectangle. And entity name, usually we use capital letter. So if you For example, employee, it should be capital letter. And using rectangle. For attributes, we use over to represent attributes. We have 3 common types of attributes. Each type have a different way to present. We have simple attributes, like if you speak about the car, we have model, we have year for making the car, we have make or type of the car. Okay, this considers simple attribute. Also for employee, we have ID or social security number. We have the gender for the employee. Then simple attribute means attribute with single atomic value, have single value. Composite attribute, it's attributes that actually consist of composed of more than one attribute. For example, address. Address could have house number, street number, block number, city, state, zip code, and country. Also here for cars, if we have attribute entity car, we have registration or the number of the car, usually have state and number. In some countries have state number and car number. Other country maybe have the type of the registration, this for foreigner, this for government, this, and give maybe letters for foreigner and letter for government and letter for normal people. Okay, then number. So it's composite attribute, have several components. Multi-valued attribute, this type of attribute could store more than one value for single or for one entity. For example, the colors for the car, maybe you have car with more than one color. For example, taxi in some countries, for example, in Egypt, have I think a black and yellow color. So cars could have 2 colors, not only 1 color. Okay, so this attribute could have multi-valued attributes. So we present it as a double oval. Okay, like this. Composite attribute, we give the name of the attribute and extract from it any sub content or sub attributes. For example, also in our example, speak about the departments of the company could be in many locations, not in one location. So you have department, the department number, manager, extra, but the location could be in many locations. So you can store many locations for one department. Thus, it's multi-valued attribute. Okay, just some examples. Here for composite attribute, as I mentioned, address could have zip code, state, city, street address, and the street address also could have number, street, apartment number. entity types. Okay, you will see some terms very similar, like sometimes you call in the book you will read entity types and entity set. Okay, entity, for example, employee Ahmad and its data. This is the entity. Entity type, all employees have a common attribute. So if you want to describe this employee or just mention the attributes of this employee or this entity, we call this entity type. So in our ER diagram, we represent the entity type, not the entity instance. When you speak entity alone without the word type, you mean the instance or the entity with its data. Okay.
Please, doctor, I have a question.
Okay, go ahead.
Is it a condition for each entity must have attributes or not?
Attributes?
Yes.
Of course. What's the important of the entity? Sorry. What's the important of the entity if it's not have attribute? Attributes means the items about this entity or the information about this entity that you want to represent it or store it in your database. For example, if you don't have any data about the employee or any attributes about employee to store in your database, then you don't need to represent this employee in your database.
Yes.
Okay.
Yes.
Okay.
Many thanks.
Okay. Some attributes of the entity type have a unique value. For example, for employee, ID number or social security number, SSN in some countries, it's a unique value. Not redundant value, unique value. Each employee, for example, have its ID. This unique value, we name it key attribute. Okay, I think here's a key attribute. Okay. What is the key attribute? Key attribute, it's an attribute that have unique value. For example, SSN for employee. For example, student number for students. For example, a project number for projects. Okay, it's attributes that have unique value. Then each attribute that have unique value, you can consider it a key. Some keys actually composite attributes. This means have more than one parts. Like in car, vehicle tag number or the car number usually consists of state and number. Both attribute, we can name it tag number. This tag number is the key. Then tag number itself considered as a key. So key attribute could be composite attribute also. Entity could have more than one key. For example, as I mentioned, maybe in your database, you can keep student number and the student ID. Kimlik number, for example, here in Turkey, but as a student, also you have student number. So when we keep your student number, it's a key because it's unique, and your Kimlik number also consider a key because it's unique. Here you have to differentiate between the relational model. Later we will speak, which is considers the tables of the database. There you have to choose one key as a primary key, as a key for your relation. But here in ER diagram, every key you have to identify it by using underline. So in ER diagram, every unique value attribute consider a key, and every key you have to make it underlined. Okay, then later, after converting it to database, you will use only one from this key as your primary key for this table or for this relation. Okay.
Doctor, I have a questions.
Okay, come on.
Each entity should have key attribute or not?
Okay. Actually, if you did not ask, later we will answer this. Why? Because we have type of entity, we called it weak entity. Weak entity do not have key.
Okay, I see.
But turn off the mic because I hear myself also. Okay. Later we will speak about key weak entity, and you can see that some type of entity consider as weak entity because it's do not have key. But we have to find solution to make it a unique when we take entity set or instance from this entity, it should be unique. So later,
why
yes,
we called him, weak entity? Why we called him?
okay, we will come to this weak entity later. Okay. During this slides, maybe after 3 or 4 slides. Okay.
Okay, doctor.
We called, I will answer you, but we will repeat it. We call this type of entity that do not have key weak entity. Why? Because this weak entity depend on another entity to become weak. For example, in company, here our example, company database, we have dependent. Dependents, this means the kids and the wife of the employee, okay? It's dependent. We keep their data for insurance issue and something like this. Here in this example, in our example for database, they keep we keep name and age, and we don't keep SSN. So we don't have for dependent entity, we don't have key. Then how to, because name could be, you could have 2 dependent, for example, employee Ahmad have his son Omar, and another employee have a son also called Omar, for example. Then name cannot be a key. Then this type of entity, if do not have a key, I need to make it unique. To make it unique, you connect it to the parent, okay, to the employee. So it's depend on the employee. That's why we called it weak. We will see some examples later after a few slides, inshallah. Okay, then if you have attributes that unique attributes, you consider it considered as a key attribute, and you have to underline it. Here, example entity set. What is the entity set? Entity set, it's the current state of the entity or entity instance. For example, here you have entity type, the name of the entity here. It's entity type. It's just a term, okay? I will show you what's the different entity types. I think it need E here. Okay, and entity type have attributes. This is attributes, and here also the attributes. Here in ER diagram, here just to show some example for entity set. Okay, car, we have example for car number, vehicle ID, and make, model, year, color. Each one of this is instance from this entity. Or in another term, we call it entity set. Actually, in ER diagram, we don't use entity set. Later, maybe we need something like this in relational model. But in ER diagram, we use the abstract way, okay? Entity type without any data inside it to represent these attributes. Okay, same thing here. For each attribute, we have the data type and some characteristic for this attribute, like the links of this data type. Like if you are in programming, said, okay, integer X, okay, or a string, and give the string links. It's similar here, the term value set. Value set means the set of values that you can give for this attribute. And it's depend on the type of this attribute. For example, last name could be from type character and length 15, for example. It's similar when in programming, making the data type integer or character or blah, and give the links for this variable. It's similar. This term called data or value set for attribute. Actually, it's not needed now in ER diagram. In relational model, we will identify the value set for each attribute. You should identify the value set for each attribute. But in ER diagram, everything abstract, okay? You give the entity type and the attributes, name and types for each entity. Okay, as I mentioned, we display entity type using a rectangle box, and usually the name of the entity type we give in capital letter. Attributes will display using oval, and key attribute should be underlined. Multi-valued attribute using double oval, like color here. As you asked me for, does every entity type have
Sorry, sorry, Doctor,
entity
I
type?
can't hear you.
Sorry?
Sorry, Doctor, I can't hear you.
You cannot hear me.
Yes.
Why?
Before 1 minute when you explain about this, but now I can't hear you.
It's okay. If entity type do not have any of its attribute as a key, we call this entity weak entity type. Okay, then
Okay, Doctor, I get it.
usually entity type have at least one unique attribute as a key attribute, but some entity type do not have any. This type of entity type, we called it weak entity because it will depend on another entity to become unique. Okay, this the symbols that we use in ER diagram. For entity, we use rectangle. For weak entity, we use a double rectangle. For relationship between entities, we have relationship. For example, employee works on department. Employee works for job. Employee has dependent. Okay, department manage a project, for example. Then we have entity and entity type and another entity type. They have relation. We present this relationship as what we call this shape. I forget. Okay, we use this shape. If you have weak entity, as I mentioned, weak entity should depend on another strong entity. That's why the relationship between weak entity and a strong entity, we called it identifying mission, identifying relationship. Why?
Please, Doctor, can I have a question?
Yes, sure.
You are mean we have three type of entity: normal entity and strong entity and weak entity.
No. Normal entity, it's a strong entity. It's the same entity type.
normal entity, it's
or
also
normal entity
called
type,
the strong
we consider
entity.
it strong. Okay, it's just, I just mentioned that it's not weak, so it's strong. So we have the entity type
Two
and
type,
weak
just two
entity
type.
type.
That's what you mean?
Yeah, just two types.
Okay.
Consider normal strong because it's do not depend on another entity.
Not
Okay.
dependent. Okay.
Okay. So the relation when you have like this entity and you have weak entity, and you have relationship, this relationship considered from identifying relationship, not like this, not normal relationship. So we use double line for it. Okay.
Because
Later
we
will
have
example.
weak entity like this, doctor.
This one weak entity.
Yeah, that's
and
why.
This one, then identifying relationship connect between weak entity and the normal entity or the strong entity. Okay. Of course, cannot have relation between weak entity and another weak entity. Because here you will have a problem. Here you will depend later in the on the key of the strong entity or on the normal entity to identify this weak entity. That's why we name this relation identifying relationship.
Doctor,
Oh,
can you make
yes.
relation between weak entity and weak entity?
You cannot make relation between two weak entities.
We can. Tamam.
Yes, because weak entity depend on normal entity or strong entity to identify it. But if you have two weak entities, this means I don't have key in this side, and I don't have key in the other side. So which one will identify these two entities? I don't have key to identify both entity. But here, when you have this identifying relationship, the normal here entity or the strong entity will identify the weak entity. For example, if I have two dependent, I have two employee dependent or two kids with the same, for example, Ali and Ali. Okay, I have two instances from dependent. They have the same name, Ali and Ali. Here in weak entity, we don't have keys, so the values could be redundant like this. So I cannot identify this one for which employee. That's why when I make mapping, I take the key from normal entity to the weak entity. So if I have first Ali, for example, for employee with number 1, 2, 3, then in this dependent data table in the database, I will put the employee number, the key from here to the weak entity. And the other employee, for example, number 3, 4, 5, have this son. Where's the pointer? Okay, here. 3, 4, 5. Here I can identify or know this entity from this entity. Why? Because I have the key here from the strong entity or the normal entity in the weak entity. That's why we call this relation identifying, because this normal entity or this entity will define or make this weak entity unique. Okay, so I can use it, but if both weak, you cannot have a common instant or a unique instant or a unique row, let me say, in the database for each instant. Okay, we have also attribute as an oval. Key attribute should be underlined. Multi-valued attribute have double oval, and composite attribute have oval and extracted from it.
I have a question, please, Doctor.
Many oval. Yes.
Please, Doctor. Is it
Yes.
possible to related to contact two weak entity between the relation?
I mentioned this, that you cannot connect between two weak entity.
Correct.
Okay.
Without unique key together?
Because if you have two weak entity, you don't have an identifier here. Okay, because you don't have key attribute in both entity. So who will identify the entity itself?
So it's impossible.
If you have not a binary relationship, a relationship between three entities, you could have two from them weak.
Yes,
because
yes.
the third one will identify both entities. But
Yes,
between
yes.
only two weak entities, you cannot do this.
Yes, it's impossible. It's done.
Okay.
Doctor, you mean three entity relationship together?
Some relationship have three entities like this. You have relationship with a three entity type. Between three entity type.
Yes.
Okay. In this way, you could have two weak entity, because you can take this identifier to identify both. Actually, in this way, you will have this entity as a table. Later, you can see this when we speak about mapping between ER diagram to convert it to database or to relational model. Okay, then tables after this. You can see that this type of entity will convert to table, and it will take keys from here or items from here, the partial key here in weak entity and the key from this entity. Okay, you have sometimes we have another type of attribute called derived attribute. Derived attribute, it's not really come from outside. It's calculated attribute. We used in SQL usually some calculation called aggregation functions and some calculation. So this calculated attribute called derived attribute. For example, age from birthday, or we have here another example. Let me check also. Okay, number of employees for department. You keep you have relationship between departments and employee, then if you calculated the number of employees for this department, it's calculated because it's this value, it changed by the time. When you add more employees for the department, this value will be changed. So you cannot make it as attribute and you enter the value, okay, we have 5 employees. No, maybe after a few weeks you will have more employees. Then this number, it's derived attribute. You calculate it in your database before storing the value. So it's usually changeable value. Okay, then we have until now 2 things: entity type and attributes. Now between entity types, you will have relationship to connect this entity type. For example, employees working on department. Maybe one of the employee manage a department. Then you have department and employee. You have 2 relationship here. When the employee working on department and another type of relationship, employees that manage department. Then between 2 entities, you could have more than 1 relationship. You could have 1 relationship, you could have 2 or 3, depending on what's the relationship between these entities and what type of data you need to track between these entities. Then ER model have 3 main concepts: entities, especially entity types; attributes, which have simple, composite, and multi-valued attribute; and relationship. Of course, relationship, we have relationship types. It's the abstract of the relationship, just the description of the relationship. And the relationship set, this term we will not use during ER diagram. Later in relational data model, you will see that how to represent this relation in your database. So you will have data for this relationship. So we focus here in relationship types in ER diagram, attributes, and entity types. Okay, then relationship relates two or more entities. Some type of relation connect the entity type with itself, for example, but it will consider also binary because it have 2. For example, employees. If you have employee, some employees supervisor for another employee. Then some of the employees have relationship with other employees. We call this recursive relationship, but it is still a binary. Why? Because we have here relation between 2 entity, not 2 entity type, 2 entity. Okay, one entity for employee X and another entity for employee Y and employee Z and employee X, for example. Okay, we call this binary relationship, it's the degree for the relationship. We usually have binary at least, but maybe we have more than binary, maybe ternary or maybe n-ary. Okay, this means more than 2. But at least we have binary relationship. This is the lowest degree because you speak about relationship between entities. So at least you have 2 entities. Okay, here show you some relationship instance. For example, we have employee E1. E1 have data name, blah, blah, blah. But to make it shorter, consider it instance from employee E1, E2, E3. And we have this the entity type employee, and this the entity type department. And we have between employee and department relationship type works for, means employee works for department. Okay, employee E1 have relation with department 1. This relation we call it works on. Then E1 relation 1 T1, this instant from the relationship, sorry, R1, this one. Another is instant, we have E2, R2 with D2. Okay, then, in short, we have employee should work only in one department. So from employee side, we have one employee work in one department. Department have many employees. For example, D1 department have relation with E1 and E3 and E6. So this type of relation, we called it one-to-many. Later, we will see how to draw it and find the degree for the relation and find the cardinality ratio. We call this cardinality ratio of the relation directly on our ER diagram. It's much easier than using this way, the relationship. Okay, this is another relationship instance between employee. What's the time now? Okay, we will have break for 10 minutes. So we continue after 10 minutes.
Okay, doctor.
Okay, doctor, thank you.
Okay, because we already
Okay,
now
doctor.
more than 1 hour.
Okay,
We will
Yes.
take a break for 10 minutes and we will continue, inshallah.
as you wish, doctor. As you wish.
Okay.
Inshallah.
Inshallah.
Okay, how many students around? Please, if you are around, just raise your hand. Okay, we still have 2 minutes for the break, so I will wait for another 2 minutes for more students to come. Okay, can continue now. We stopped here. It's another example for relationship between employee and project. This example said that employee can work on many projects. Employee can work on many projects, and project can have one project and have many employees. For the ratio or cardinality ratio, okay, we choose usually the maximum value from n and 1, so we choose n. From 1 and m, we choose m. So we know that this relationship, it's many to many relationship. This means employee can work on many projects, and the project can have many employees. Okay, as I mentioned, later we will see it directly in the ER diagram without the need of drawing it like this. Okay, I think we can start now our example to draw ER diagram. Okay, let me. How many students are around now? I need to know. Please raise your hand again.
Yes, doctor, we are here.
Yes, doctor.
Just use this one to raise your hand. Okay, good, very good.
Okay.
Then we can start this example. I think too much how to draw this example. We could draw using, for example, eDraw Max, but the issue, we will not have the description for the example with us. So finally, I decided to make it using PDF. So we have here the description for the example. And here we will try to draw our ER diagram. Okay. First step for the design, collecting and analyzing the data. Then you will have description for the data like this. This comes from software engineer usually that already meet with the customer and know from his description what type of data need to be stored in the database. So first thing, if we have description like this, we need to identify the entity type. Let's use this marker to get from this description. From this description, we want to get the entity type. In your mind, what is the entity type? Entity type, the objects or the things that we need to keep data about it in the database. So let's read. The company is organized into departments. Each department has a unique name. Look, we start here to speak about data about department. We need to keep data about department. Unique name, unique number. Then here directly we understand that department is entity type. So entity type, we use rectangle to draw it. Okay, then we have entity here. Let me just, I will write here and move it here. It's more simple for me, okay? Department. And we said it's better to have it as capital letter. Okay. Then we get the first entity type, which is department. Continue. And a particular employee who's managed the department, we just focus here. First step, we will focus on just get the entities. Okay. This description has the attributes and have the relationship. We will not take now first step the relationship and the attribute. Just focus now first step on what entity type we will have. Okay, we keep a track of the start date, employee, begin, manager, no entity until now. A department controls a number of projects. Each project of which has a unique name and a unique number. Then, from the description, we know that we need to keep the name and unique number and single location for the project. Yes. Then this project also entity type, because we need to collect data about the project and store this data in the database. Then we have another entity. Let me draw it here, which is projects. Capital letter. Okay, good. Then until now, we get two entities from the description. We continue. The database will store each employee's name, social. Then I want to store data about what? Employee name, social security number, and then I need to store data about employee. If I need to store data about employee, then this employee also entity type. Okay, then I have entity type employee. Okay, continue to read the description. Is assigned to an department, but okay, it is required to keep track of the current number of hours, also about employee. Blah, blah, blah. The database will keep track of the dependents of each employee for insurance purpose. May have a number of, including each dependent, first name, sex, and birth date. Then we need to keep data about dependent. Then dependent will be, sorry, I prefer to, okay, to highlight it. Okay, then we have also another entity type, which is dependent. Dependence means the kids and the wife or the husband of the employee. Okay, good. We finished here the description. We have 4 entity attribute. Now, I prefer next step to have the relationship before attributes. For me, I prefer to have the relationship before the attributes. Why? Because some relationship will have attribute. We will see this later. Some relationship will have attributes also. Let me just organize this a little bit. To have more space for attributes. Okay. Then I will start next step to identify the relationship. I will give it another highlighting color. I will use this highlighting color. Now, let's think about this. What is the relationship? It's to connect between 2 or more than 2 or more than 2 entities. So if you find relationship between 2 or more entities, then it's a relationship type. The company will is organized into each has data and a particular employee who manages. Usually you will have this relationship as verb. Okay, so we have employees here, it's entity and department, and there's relation between them, that employee who manage the departments. Okay, then I will draw this shape first. It's not that easy in maybe another editor will give me more flexibility, but here, because I need the description also. Okay. Then between department and employee, we have relationship. Control C, Control V. It's the best way, yeah. You will see that it will be much easier to use some editors, like even Word will be much easier. What we will call this relationship, we will call this manage or manage. Okay. Continue for the description. We keep a track of the start date when the employee begin managing the department. You see this part, it's keep a track, this mean attribute, but this attribute for the relationship, we keep a track of the start date when that employee begin managing the department. Then this attribute comes from this relationship. It's not belong to employee alone. It's not belong to department alone. It's belongs to the relationship between the department and the employee. So this attribute for the relationship. So in some cases, you have attributes or items that will be stored depending on this relationship. We give this attribute for the relationship. Okay, it will be difficult to draw it there.
Please, Doctor, can I have a question?
Yes, of course.
How are we know that's attribute belong to management, not to employee or department?
Okay.
How do we know that?
Okay. Okay. From the description, you look to the description now. I mentioned that. Okay. Employee who manages the and a particular employee who manages the department, we keep track or keep data or keep something like this means attribute data we want to store. Okay, continue. Of the start date when that employee begin managing. Here managing, we mentioned the relationship. Oh, it's difficult to, maybe I can highlight it again.
I can see it, Doctor. I can see it.
Okay, managing the department. Okay, then this is start day. If you will understand it like this. Is it belong to the employee entity or belong to department entity? Actually, it's not belong to employee alone because it's connection between employee and department. When this employee start or begin managing the department, then you have this managing, this verb managing, okay? Same here, managing. Then here you understand that this is starting date connect between employee and department. When this employee start to manage this department, it's clear that it's about the relation between department and employee. So if this attribute that you want to keep data belong to that connection between the two entities, then it's part from or it's about the relationship. From the description, you can understand it actually. It's all attribute will be clear that, okay, we keep track about employee, blah, blah, blah. We keep data about department, blah, blah, blah. But this type of attribute, we keep track about employee who managing this department. Then you have two entities here for this data. This means it's this data or this attribute for the relationship between these two entities. Okay, hopefully you get this point. You get it? Is it clear or not clear now?
Yes, Doctor, it's clear.
Yes, Doctor.
Okay. Actually, you need to focus on the description to understand it. It's all about description. If description have problem, then you will not draw it correctly. Okay, just make more space here. Okay, we continue. A department may have several locations. It's about data also. A department controls a number of projects. Okay, you see, you have two entity, department and the project, and you have here relation controls a number of a project. Then department controls a number of a project. It's a relationship between department and the project that department control number of projects. Let me just copy this one. It's better than drawing it again. Need more space, I think. Sorry, maybe here it takes more time. Okay, what we will name it from the description, control. Okay, we continue. Each of which has a unique name, a unique number, and a single location. The database will store each employee name, blah, blah, blah. An employee is assigned to one department. When you see in this, in some one sentence, two entity mentioned, you directly have to focus to know if we have relationship between two entity here or not. Here, an employee assigned to one department. This relationship between employee and department, it's another relationship. We have first relationship, manage. We have another relationship between department and employee, that employee assigned to department. Assigned to one department, but may work on several projects. It's another one. Now we will have this one assigned to department. Okay. Then we have relationship, another relationship between department and employee, and this relationship that we have employee assigned to department. You can give name for this relation, assigned to or work for. Okay, you can use anyone. Just you need to understand the relation. So it's better to give names that give you a clear understand about the database. Don't use A, Z, A, Q, this short terms. Assigned to. Okay, we continue. But may work on several projects. Then who work on? Employee. Employee work on, may work on several projects. Continue for the description. Several projects which are not necessarily controlled by the same department. Okay, good. This have too many information. This small sentence have too many information. Now, this relationship, some student will make confused that we have here mentioned department and project and employee. Oh, it's three relationship between three entities. No, it's not between three entities. If you focus here, employee works on several projects. We finish here, which are not necessarily controlled by same department. Then department not part from this relation. The relationship directly between employee and the project. If you remove not necessarily controlled, this means this work on could be connected between department, project, and employee. But because it's not necessary to be the same department of the employee, then no need to connect department with this relationship. So this relationship directly between employee and the project, because not necessarily this employee work for same department or his department. Okay. Let me copy and paste this. Then it's relationship between department and employee that employee may work on several projects. Then this, we will call it work on. Okay, we continue here. It is required to keep track of the current number of hours per week that an employee works on. You see, it's directly named the same relationship. So you understand that number of hours, this one per week, this data, this entity belong to work on, not belong to the project or belong to employee. Then this attribute, hours per week, it's belong to the relationship. It's same like start date. How do you understand it? Because from the description here, it's connected to the relationship. That employee works on each project for how many hours? It's very clear that this belongs to the relationship. When you bring the project and employee connect between them, then you have the working hour, because employees that not working for a project will not have working hour, and the project cannot have working hour for all the employee, or some projects still do not have employees that or working hour for the employee. Then when you connect between these two entities, you get this working hour. Then you understand here that this attribute, which is working hour, belong to I have problem in my mouse. Let me just try to change the batteries of the mouse. Just 1 minute.
Okay, doctor.
Okay, doctor.
Okay. I don't know where the battery is. Okay. I will try to move the mouse. Okay, my friends, please your mic, turn off your mic. Hello. Could you please turn off your mic? Okay. We have this entity hours or working hours. Okay. It should be not capital, only first character. Oh. Working it's enough here. This one also. Start date. Okay, we continue to read the description here, as well as the direct supervisor of each employee. Then each employee have direct supervisor between practice who is another employee. Then employee and employee. It could be the same entity, but it's different instance. Some employee supervise another employees. Then we have relationship or recursion relationship between employees and another employees, like this. I will draw it again. Okay, sorry. We call this recursive. Why? Because from this entity to the same entity, some employees and another employee. Okay, some employees and another employee. It's different entity, same entity type, but different entity instance. Okay, then it's relationship. Then we have here supervisor as a relationship between employee and another employee. Let me draw it here. Do you have any class after this class? Because seems our class will take more time.
Yes, doctor.
Oh, no problem. No problem.
Okay, nice. Because we need to we cannot cut the fluency of this subject in the middle. Okay. Sorry. We speak about the relationship between employee and employee. So let me draw it like this. Okay. And
Doctor, it is called recursive.
Doctor,
yes.
Okay.
Doctor, most of PhD students have a mobile Cypress class start at 7 o'clock.
Who have this class?
Most of our colleges who doing PhD program. Maybe
how many? Sorry, how many students around have a class at 7? Please just write me
That is good because, Doctor, when I suggest on you on the Telegram to make it on 5 o'clock, they send to me a message and objected. Why do you say that we have a class at 7 o'clock?
Then is it better to have it at 4 o'clock?
I think that. I don't want to talk because I am already don't select mobile service class. I don't have a class at this with them,
Then,
so I will not talk.
Okay, then we
It
have.
is okay for me if it at 4 or at 5. Maybe
How
you
many
can write in that.
Okay, thank you. How many students have class at 7?
Me, I have.
I will write number 1.
Omar and okay, I will try to make it fast now, and starting from next week, inshallah, it's better to make it at 4.
Doctor, excuse me. Can we shift it to another day for future lecture? For example, maybe Friday or another day, because when we make it in this time, we will have 2 exams in future in the same time, in the same day. Sorry.
No, exam. It's I will not shift it officially. Okay.
What you mean, Doctor? Sorry.
I will shift it between me and you. You.
Okay,
I mean the student,
okay,
not
that's
official.
right. You can shift it at any
Okay,
time.
Doctor,
But
at
actually,
least
it's difficult for me to move it to another day. If you don't have
Doctor,
classes, it's better for both of us.
Doctor, how about the mid final or mid exam or final exam? Maybe we have 2 exams in the same day.
No, it's. I don't think so. It's not depending on the class day.
pardon, Doctor. From our previous in this previous semester, the exam are in the same day of the lecture.
Okay.
So my friend suggests
our
that
official time for this class will be on Monday.
yes, you are right.
I will not change it in the system officially.
That's clear to us.
Okay.
What my friend mean that we will take the class, for example, after dealing with you
I
on
suggest.
Wednesday.
Sorry for that. I suggest let us continue this 10 minutes, okay? And we can discuss on Telegram. I think it's better because we need this 10 minutes actually.
Okay, Doctor. Continue.
Okay.
Yeah, sorry.
Yeah.
Okay. Let's move forward more faster. Then this supervision, this relation supervision. Okay. Let me. Supervision. Is it 1S or 2? Yeah, it's 1S. Okay. This type of recursive relation need to be clear. What do you mean by this relation? So you need to identify each connector will for whom you have employees, some employee supervisors and some employee supervise. Okay, then you have supervisors that have relation supervision with some employees. We call this supervise. So you need to write it here on this connector. So we have the relationship from this type of employee that we called it supervisor with another type of employee that we called it supervise. Okay, then I need to mention it. Supervisor. This means this relation come from employee, which is supervisor, to another employee, which is supervise. Supervise. I'm not sure about the spelling for supervise. Supervise. Yes, it's one E, not double E. Okay, then just this type of relationship, which is recursion relationship, you need to identify the connector. This employee, the supervisor employee, have supervision relationship with another type of employee that supervise. Okay, we continue here. The database will keep a track of the dependents of each employee. Then, dependent of each employee for insurance, blah, 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 blah. Okay. Then, we have two entities, dependent and employee, and we keep track for the relationship between dependent and employee. We can name this relationship dependents of the employee. Then dependents of the employee. Okay, then we can draw this one. I will try to finish it quickly now. Because it's too important to understand how to draw ER diagram from the description. Okay, if we use a software for drawing, it will be better for organizing our diagram. But as I mentioned many times, I do it here because it's better for description and for example. Okay, for our example, we have dependent of. Okay, like this, we finish the entity and the relationship. Now we can start with the attributes for each entity. About the attributes, I will take another color, maybe yellow. Oh, we already took yellow. Okay, we can take this color. The company is organized. Each department has a unique name, unique number. Then you start to read what type of data for each attribute. A particular manage, then this is not data, not attribute. A department have several locations. the term here, several, this means location multi-valued attribute. Okay, then for department, we have 3 attributes. Name, which is unique, this means it's a key. Number, which is also unique, this means it's a key. I will give you for the department, and you can continue for other, okay, for other entity, okay?
Okay, doctor.
Withdraw, because I don't want to I know time's up, so I will make it more quickly. Oh, I thought I had problem here, but alhamdulillah, no problem. Okay. This attribute. Okay, I will try to write it like this. We have a name. Is it possible to write? Oh, it's difficult. Name. And name, it's a key. So you will have like this, underline. And we have also number. Let me write it like this, which is also a key. So it's underlined. Why it's a key? Because unique number, unique name. So this one key, this one key. And several location, this is multi-valued attribute because you have several location. So location. Okay. Okay, enough for today. So at the same way, you can start to read here for employee and for projects, and then for dependent, what type of data you need to keep for each one. Then you will draw your ER diagram, okay? This ER diagram still needs some job, like identify the cardinality ratio for this relation, 1 to many and many to many, 1 to 1. We will know how to define it, inshallah, next week. That's enough for this week. We are delayed here for our schedule because we should finish ER diagram today. So inshallah, next week, maybe we will take more time. So I prefer to start 4 p.m. next week, inshallah. See you, inshallah, next week.
Inshallah.
Thank you for
Thank you.
attending our class.
Thank you.
Thank you, doctor.
Thank you,
Thank you.
doctor.
Thank you,
Good
doctor.
night.
Doctor,
See you, inshallah, next week. Have a nice week. Okay?
have a nice.
Thank you, doctor.
Very
Doctor.
soon. Assalamu alaikum.
Alaikum assalam.
Doctor,
Thank
can I
you,
speak with you?
Thank you.
Doctor, can I speak with you about the lecture timing?
We will discuss about lecture time using Telegram group.
Okay, I'll write a message about because I talked with my
Okay.
friend and we have one suggestion to you.
We have 1 week until next lecture, so we have time to discuss and make the best for everyone, inshallah.
Okay. And if I some question
Okay.
about the subject, do I email you or write in the Telegram?
No,
Which is
I
better?
prefer to write in Telegram group so everyone get benefit from the question and from the answer.
Okay. Okay, that's good. Very good. Thank you, Doctor.
Okay. Thank you. Thank you. See you inshallah next week. Salam
See you,
alaikum.
Doctor.
Yeah.
See you. Salam alaikum.
See you.